Salam, peace be upon you. My name is Mohammed Layak Siddiqui, the father of Holophase. We have come to a turning point, and I want you to feel why it matters before we touch a single symbol. Up to now, we have been building the rules of a language that refuses to cheat. We began from the silent ground. Undifferentiated phi is not a thing and not a substance. It is the permission layer that makes any same and different meaningful at all. Then we introduced a single primitive token that we are allowed to write, a phase-like assignment on a circle. We called it phi. We gave it a home, x, not as a container of space and time, but as the minimal support, a patchwork of neighborhoods where we can speak locally and then compare what we said on overlaps. We raised absolute phase by installing the gauge quotient rule. Shifting the whole phase by a constant does not change the world. We installed regularity typing, so we cannot pretend we can take derivatives where derivatives do not exist. We learned the lift discipline, how to unwrap a circle locally to a line, so calculus can touch cyclic data without breaking it. And when the domain is not simply connected, we learned branch cut declaration, how to be honest about where we cut the map so the unwrapping can be single-valued, while insisting that true structure never depends on our cut. All of that was preparation for one step. Now we finally let the language speak its first action word. We take the derivative. And that first derivative word is what we will call A. I'm going to keep this extremely simple and extremely honest. In Holophase, change is not a vague feeling. Change is a specific kind of sentence you are allowed to say. If you want to say, it changes, you must route your sentence through this first derivative word. If you cannot do that, then in this language, you do not get to claim change at all. So let's open with an image you can hold. Imagine a melody you know well. You can hum it even without remembering the lyrics. If I ask you, what note is being sung at this exact moment? That is one kind of description. That's like phi, the value at the moment. But if I ask you, is the melody rising or falling right now? Is it climbing quickly or slowly? That is a different kind of description. That is not a note. That is movement between notes. That is slope. That is change. Our first derivative word, A, is that slope sense made precise, not only along time, but along any direction you can move within the patch of the world you are describing. Now let's state the key equation, slowly, and explain every symbol. The defining equation is A is equals d phi, comma. A is defined to be d phi tilde. Now what does each piece mean? 1. A, capital A, is the name we give to the first derivative object. Think of A as the change field. It tells us, locally, how the unwrapped phase is changing when you move a tiny amount. 2. Means is defined as. It is not a claim about the universe yet. It is a declaration of language. We choose to use the symbol A as shorthand for something we already know how to talk about. 3. Is the derivative operator in this language. You can think of it as the cleanest, most general way to say, how much does this change when I move a tiny amount? It's the formal version of slope. Phi is the local lift we introduced in part 5. It is crucial to remember, phi lives on a circle, but phi lives on a line. Phi is the locally unwrapped version of phi, chosen only on a domain where that unwrapping is allowed. So A is not the derivative of phi directly. We do not do that. We never do that. Phi is circle valued, and circle subtraction is ambiguous at the wrap point. The only honest way is unwrap locally to a line to get fun, then differentiate fun, and only then talk about change. That is the entire meaning of A equals d fun. If you remember only one thing from this part, remember this. A is the first honest word for change because it is built from a lift and it survives all the freedoms that make the lift arbitrary. Now let's anchor that idea with the two invariance freedoms we have already installed and show why A is public and not private. First invariance, the global gauge shift on the circle. Earlier, we installed the rule that absolute phase is not meaningful. Formally, we said shifting phi by a constant does not change physical meaning. You can express that idea as phi is tilde phi plus c. Phi is equivalent to phi plus c. Here, phi is our circle-valued field. C is a constant shift, like rotating the whole circle by the same amount everywhere. The symbol tilde means physically equivalent in the sense of the gauge quotient. Different representatives, same structure. Now, how does this affect A? If phi shifts by c, the lifted version phi can shift by the same constant c, because if you rotate a circle, the unwrapped coordinate shifts too. So you can write on a lift-valid patch, phi e to phi e plus c, phi tilde goes to phi tilde plus c. Now apply d, the derivative operator. D to phi e plus c is equals d phi e, because the derivative of a constant is 0. A constant does not change as you move, so it contributes nothing to slope. So if A is equals d phi e, then under this global shift, A stays the same. That is one reason A is public. It does not depend on where you place the 0 around the circle. Second invariance, the integer lift ambiguity. When you unwrap a circle to a line, there is another freedom. If you go around the full circle, you add a full turn, which is 2 pi. That means there are many valid lifts that all wrap back to the same phi. If one lift is phi, then another lift is phi plus 2 pi n. Phi tilde goes to phi tilde plus 2 pi times n. Here, 2 pi pi is the length of one full turn around the circle when we measure angles in radians. N is any integer. -2, -1, 0, 1, 2. Adding 2 pi n means you chose a different sheet of the unwrapping, but when you wrap back onto the circle, it's the same circle point. Now apply the derivative again. d of phi plus 2 pi n equals d phi, because 2 pi n is also a constant. So A is also invariant under the lift ambiguity. It does not care which sheet you chose. That is the second reason A is public. So we can now say, in simple words, A is the first derivative word because it is the first object that describes change while being immune to both kinds of arbitrary choices. The choice of 0 on the circle and the choice of which turn count you used when unwrapping. Now I want to make one more essential clarification for the listener because it prevents a common confusion. A is not a thing. A is not a substance. A is not an extra ingredient added to phi. A is a sentence you are allowed to say about phi once you have done the lift honestly and you are standing on a patch where differentiability is permitted. A is structure extracted, not structure invented. This is how Holophase stays disciplined. We never add primitives to escape difficulty. We change the kind of question we ask. We go deeper, not wider. Now let's place A inside the 4 firewall gates, but in everyday words. This is important because it turns this part into a discipline that cannot be cheated. First, the well-formedness gate. What counts as a valid sentence here? The rule is, A exists only where the lift exists and is differentiable. That sounds technical, but it's just ordinary honesty. If you cannot unwrap phi to a single-valued fini on your domain, then you cannot take dfini, so you cannot speak of A there. If you can unwrap, but the patch is not smooth enough, If it is only continuous and not differentiable, then slope is not defined, and you cannot speak of a there either. Think of drawing a line on paper. If the line is smooth, you can talk about its direction at a point. If the line has a sharp corner, direction at the corner is not a single answer. You can approach from one side or the other and get different directions. The corner is still real, but the derivative there is not defined. Regularity typing from part 4 is exactly that. If a patch is typed as C1, derivatives exist. If it is typed as only C0, derivatives do not exist. So A is a C1 word. So WF for this part is no A without C1 and no A without a lift. Second, the invariance gate. What must not change when we change representations? We already felt it. A must not change when we shift phi by a constant, and it must not change when we shift the lift by 2 pi n. In simple words, if your change depends on your choice of 0, you have measured your pencil, not the world. If your change depends on which turn number you used when unwrapping, you have measured your bookkeeping, not the world. A passes the invariance test by construction. Third, the domain gate. Where is this sentence allowed to live? This is where many people accidentally cheat without realizing it. So we say it plainly. If you write A, you must say where it is defined. If your domain has a branch cut B, then the lift fan is defined on P/B, meaning the patch P minus the cut set B. That means A is defined there too. So A is not automatically defined everywhere. It is defined on the domain where the lift exists and where differentiability holds. And your sentence must be honest about that. A claim of change without a domain is like claiming a recipe works without specifying ingredients. It's not false, it's incomplete. And in this language, incomplete means illegal. Fourth, the non-encodability challenge, the guard against inventing new primitives. Here is the temptation. Someone sees complicated behavior and says, A is not enough. We need a new change substance. The firewall says, prove it. If the proposed new change object is actually just a function of A and higher derivatives of A, then it is not new. It is derived. It is a description, not a primitive. So the NEC challenge here is simple. Before you add a new change primitive, you must show it cannot be written using A and its higher jets on lift-valid domains. This is how we keep the vocabulary minimal and powerful. Now, I want to give you the most intuitive definition of A you can carry in your bones. A is a rule that turns a tiny movement into a tiny phase change. That's it. That is what a derivative object does. You move a little in some direction, and A tells you how much the unwrapped phase would change to first order. If you want an everyday analogy, imagine a hillside. At each point, you ask, if I take one step north, how much does the height change? If I take one step east, how much does height change? The collection of these answers is the slope information. That is what A is for the unwrapped phase, Fran. Now, in older physics, people often rush here and immediately talk about time and space. But remember our triunity law. Time, space, and motion are not independent primitives. They are readouts of the same derivative structure. So we keep it disciplined. A is one object. Later, it will echo as three inseparable readouts: omega, kappa, nu. But we do not treat those as three new things. There are three ways of reading the same stem A. To make that feel real without introducing forbidden primitives, I'll phrase it like this. Whenever you have a change object A, you can read it in different directions of your patch. One direction will later be understood as temporal cadence, another as spatial texture, and the coupled remainder as transport. but they are not separate. They are shadows of one lamp. A is the lamp. Omega, Kappa, Nu are the three shadows. Even if we do not name the shadows yet, A already contains the tri-echo, because any directional reading of change splits naturally into along one direction, along another, and how the pattern moves between. Now let's show how A helps you avoid a deep kind of confusion, confusing a label for a structure. Return to the melody analogy. If I transpose the whole song up by one key, shift every note by the same amount, the melody is still the same melody. The contour, the rises and falls, the rhythm of change stays the same. That contour is like A. The absolute key is like Phi's global shift. A ignores it. That's the spirit of gauge invariance, translated into music you can hear. Now let's bring in another analogy that matches the earlier parts, the clock face. A clock hand points to an angle. That's Phi. But if the hand passes from 11:59 to 12:01, the angle wraps. If you just subtract the angles as if the circle were a line, you might think the hand jumped backward almost a full circle. The lift Phi fixes that by keeping track of the turn count. Now the change is small and correct. And A is the speed of the hand, computed from that unwrapped angle. That is why we insisted on the lift discipline. Without it, change near the wrap point becomes nonsense. Now I want to address something that often intimidates people, the word derivative. We can keep it simple. A derivative is the answer to one question. If I move a tiny bit, how much does this number change? That's it. And in Holophase, we have one special complication. Our primitive value is cyclic, not linear. So we first unwrap it locally. Then the derivative is ordinary. Now there is one more sentence we can mention, carefully, because it gives you a deep feeling for why A is such a powerful first word, without drifting into forbidden physics. Because A is defined as D of something, it automatically has an internal consistency. In everyday terms, if a change field really comes from a single underlying lifted value, then tiny loops should not produce contradictions. Let me make that vivid. Imagine you are on a hillside. You measure the slope. One step north gives you plus 1 meter. One step east gives you plus 2 meters. Now walk a tiny square. Step north, then east, then south, then west. You come back to the same place. If your slope measurements are consistent, your total height change around the square is 0, because you returned to where you started. If your measurements say you gained height after returning to the same point, then something is wrong. Either there is a cliff you crossed without admitting it, or your slope field isn't really derived from a single height function. That tiny loop consistency is what the derivative of a derivative rule captures. In symbols, in the formal language, people write d phi equals 0. D of d phi tilde equals 0. This looks scary, but it's just a statement. If A is truly the derivative of shn, then the derivative of A has a special constraint. It means your local change field doesn't contain a hidden contradiction inside a smooth region. And we can rewrite it using A is equal diffn. If A is equals diffn, then dA is equals 0. dA equals 0. Again, do not interpret this as an equation of motion or a physical law right now. In episode 13b, we are not doing dynamics. This is language hygiene. It is a consistency check that comes from the definition of A as a derivative of a lift. And just like the hillside example, if you find yourself in a region where this consistency fails, it usually means one of two things in our language. You are not in a domain where a single valued lift exists. Maybe there is a topological obstruction, a defect, or you forgot a branch cut. Or you are trying to speak beyond the declared regularity. Maybe you are using second order talk where only first order smoothness exists. So even this small symbol, dA equal to 0, is a firewall tool. It helps you catch where you cheated. Now let's give a few more analogies across scales, scattered like stepping stones, so this idea becomes unforgettable. First, weather. A weather map might show pressure values. Those absolute numbers are less important than the gradient, where pressure changes quickly. Wind responds to differences, not the absolute number. A is like that gradient of the unwrapped phase. It's the thing that actually drives structure later, without us needing to call it force yet. Second, weaving. Think of a woven carpet. The color at a point is like phi. But the pattern, the direction the colors change, the way motifs repeat, the edges where motifs turn, is in the local transitions. A is the local pattern direction. If you dye the whole carpet slightly darker, the pattern is still there. A is the pattern, not the global brightness. Third, biology. In an embryo, cells don't just read a chemical value. They respond to differences, how the concentration changes across a tiny distance. That difference is what tells a cell you are near the head end or near the tail end. That local difference field is like A. The absolute chemical amount can shift, but the gradient still guides structure. Fourth, daily life. Imagine a road trip. Knowing your exact location is one kind of information. Knowing your speed and direction, how your location is changing, is another. A is closer to speed and direction than location, and the speed and direction are what determine what happens next, without needing to assume a story about where you're going. Now, I want to bring the listener back to a simple, clean summary of what A gives us, because it changes the entire grammar of what can be said. Before A, we could only label events with a cyclic value. We had nouns. With A, we can talk about variation. We have our first verb. And once we have a verb, we can eventually build sentences like, this pattern is stable, this pattern winds, this pattern concentrates, this pattern cancels. But again, not yet, not in this part. Here we are only birthing the first verb. Now let's state the prediction and falsification for this part, but in the grammatical way you required. Prediction. Any later dynamical vocabulary can be rewritten as patterns or constraints built on A and higher jets. In plain words, if later physics tries to talk about motion, fields, forces, waves, or anything like that, in Holophase it will be translated into how A behaves and how A's derivatives behave within declared domains. Falsifier. Present a local, publicly meaningful change descriptor that cannot be written as a functional of A and higher jets on lift valid domains. In plain words, find a way to talk about change that is truly public, truly local, and cannot be expressed using A once a lift exists. If you can do that, then A is not the first complete change word. The language would be incomplete at first order. Now, we should be honest. Such a falsifier is hard, because A was designed to be the most general first-order description of change. If you claim there is another kind of first-order change, you usually end up describing a projection or transformation of A, meaning it wasn't new. Now we need to close this part in the style of episode 13b. One memorable sentence that seals what the listener carries forward, and a bridge to the next part. But before we do that, I want to return to triunity one last time, because part 7 is where triunity stops being a slogan and becomes unavoidable. We said earlier, time, space, and motion are inseparable readouts of one evolving structure. In Holophase, we do not start with a time axis and a space grid and then place a field on top. We start with a field that becomes readable as change. A is that readability. Once A exists, you can read its change in three inseparable ways, because any structured change has a cadence aspect, how it accumulates along one direction you later call time, a texture aspect, how it varies across directions you later call space, and the transport aspect, how the pattern itself shifts relative to the directions you're using. These are not three different ingredients. They are three faces of one derivative stem. That is why triunity is not optional. It is already sitting inside A, waiting to be read. We are still obeying PS0 purity. We did not introduce metrics or connections or causal order. We did not call anything particle or field substance. We simply acknowledge that A, as a first word of change, is rich enough to have three inseparable echoes. Now, seal it. Here is what you should carry in one sentence. A equals d phi tilde. It is the first honest word for change, built only after unwrapping the circle, defined only where the unwrapping is allowed, and invariant under every arbitrary choice we could have mistaken for reality. And now the bridge to the next part. Once we have A, we are no longer stuck with only first-order change. We can ask, how much structure can we read locally if we are allowed to differentiate again and again, but only up to the regularity the patch truly grants? That next step is the jet alphabet. Finite jets, the controlled, typed stack of higher derivatives that lets the language speak with more precision without hallucinating extra physics. So we step forward next into part 8, the finite jet vocabulary, the alphabet that grows from this first derivative word while staying firewalled, typed, and representation independent. Always peace be upon you.